Dear friends, sorry for that. I I could not actually. What to say? Well, good morning back to you. I tried new version of Facebook rather than classic course. In beginning when I started, message was there. You use this and don't use other one. But unfortunately, I use for video. But when I tried to share screen, I was not allowed to do that. There was no entry sign on that. Means they are not ready with new version, but they want people use that one. This is really unfortunate that they they want to force you at this moment when they are not ready to use that version. So that's not right way. That's not at all right way. Means they should not do that. But well, I closed that video by mistake. I could not shift to show this screen share which I am doing now. The screen share which I am doing now, and you know that it's of course very important one that I am doing now. I am going to same file which I did that. I am going to same file that is this file of material testing laboratory, and this is soil report, a soil report of a mega project. I would like to show you this table of contents only here, which you can go through this. You can self introduction, project description, site description, prevailing conditions, general geology of area, field exploration, testing and drilling, execution trial pits and soil activity, electrical registry testing and thermal registry testing, laboratory testing, surface and subsurface conditions. I'm just telling you trials, and then general discussions for choice, suitable foundations, and conclusions and recommendations. And all these are there in this report. Too much is there in this report. Yesterday I tried to give this information, but because of failure, failure, I just jumped to phase 45 now, not to waste time anymore. So that is here. We have to go through. I think I talked from this. You think so? Foundation concrete. I started yesterday. I could not show you this page because of non-availability of screen share. Now by chance I shifted back to classical form classical format of Facebook, and I could get this one. So this is page 46 of that report, which I am now projecting to you directly. And of course I will show you other one also. That is you can say is FIDIC, that I'll show you also that one. That is FIDIC. Meanwhile, means FIDIC and both I'll show you this FIDIC too. In this, we had gone a long way to discuss, and we shall discuss this too also after following a brief on this one, on my report, on this not my report but foundation concrete. I'm sorry. Now just give me 1 minute. Meanwhile, you can read this report. This is a very interesting one, and once you read this is foundation concrete, and if you think I can explode it more, I can blow it more. Purpose is communication should be clear, and that's more important. Just give me a minute. I'll go to room for some. cannot have these people. Well, I am very upset, wasting time for nothing, because these Facebook people are not ready with their product, but they want people to use that. It happened many times. Last time also, I lost my video due to that. Well, this time no problem. Let us see what happens. What happens has happened now. It's page 46. So I have gone through this verbally without telling you, showing this. But I think it's better if you read this file. This is foundation concrete. Now, result of chemical analysis for soil and groundwater in sites are given in table at sector D917. We will see methodology of assessment of ground for chemical agents aggressive for concrete has been based on latest publication concerning assessment of exposure conditions and specifications of concrete to resist chemical attack. Now they are giving reference of BRE Specific Digest 2001. That digest is 1. Concrete in aggressive ground. CIRA publication C577 2002 Guide to Construction of Reinforced Concrete in Arabian Peninsula. A classification of severity of chemical attack is based on foundation soil sulfate content as well as type of exposure conditions. In accordance with BRE Special Digest 1 2001 and considering existing site conditions and prevailing hostile climate UAE, following preliminary design chemical classification for concrete may be proposed, subject to following provisions: cast in situ concrete for general use with section thickness 140 to 450 mm, well compacted with no face exposed to concrete. Now it's within soil, no groundwater, location of foundation is there's no water, DS class is DS1, ACS class is AC1, design chemical DC1 and DC2, number of types of additional protective measures APM, etc. are given all there. Now this classification doesn't reflect significance of chloride ions in concrete surroundings. No such cases. Site exposure conditions should be studied in conjunction. Modified recommendation of concrete mix design based on local experience in Gulf region. CIRIA production C577 2002 Guide to Construction of Reinforced Concrete Arabian Peninsula. Further to propose design chemical class and in accordance with Table 6 of BRE Special Digest 2001 and Tables 5 and 52 of Syria Production C577 2002 following concrete specification may be considered. Now this is very old, actually this is 2000 something, so but we have to understand each and everything. Now location of foundation is within soil, no groundwater, chloride contents be insignificant, DC class DC2 and type of cement Portland cement content BS12, water cement ratio by mix 0.5, 0.5, cement content 340 kg minimum per meter cube and protective measure none. Now modified or confirmed design recommendation shall be a responsibility of designer who shall finalize specification considering design, structural performance level, section thickness, dihydrostatic pressure, local availability of aggregate. Concrete design and construction details shall be in accordance with project specifications. Project specifications shall take precedence over requirements of this report, and project specifications are always more important than something else. Notice given there is no widely accepted view of concentration at which chloride becomes significant in soil or groundwater, but limited experience in Gulf regions suggests they may be as low as 0.05%. Particular in situations where alternative wetting and drying or capillary rise affect concrete. Reference CIRA Special Publication 31 1984. Now, tectonics of southeast region of Arabian Peninsula. Earthquakes are related to crustal movements and occur mostly frequently where faults are of a recent origin. If earthquakes have occurred in past, occurred in a particular region, which is characterized by some particular tectonic structure and history, and it's assumed that earthquakes are likely to arise in future along whole length of zone. Who is this? Raja Ram is calling you. Why is calling? For what? Why? Just nothing, Disturbing for what I don't understand. These people are having to know what, where I forgot what I was doing. It's bloody nonsense, really. What I was doing. This just disturbed me. idiots, what I should say. They don't understand the importance of job, the importance of work, so they don't understand. Earthquakes are related to crustal movements. Crustal movements occur mostly frequently where faults are of recent origin. If earthquakes have occurred in particular region, which is characterized by some peculiarly in tectonic structure and history, and is assured that earthquakes are likely to arise in future along whole length of that zone. Now, Oman Mountains form together with Zagros Mountains. We talked yesterday, we cannot show that. Oman Mountains form together with Zagros Mountains a great mobile belt. This appeared in late Cretaceous period with organic movements occurring from Turkey and Iran, extending to Oman in late Tertiary period. Rocks were folded and crusted to form Zagros and Oman mountains and their forelines. Adjoining mobile belt is comparatively stable interior region of peninsula whose rigidity is controlled by Precambrian basement, exposed part of shield as well as that part thinly veneered with shelf sediments make up this province. Now figures show major faults, and that I'll show you this figure. And this is seismicity and earthquake area of southeast region of Arabian Peninsula. Detailed literature search conducted by us about seismicity of project area show that there is very limited information and data about UAE and whole region. Recommendation of BRE note are based on limited data available and in our opinion reflects common engineering practice. There are no other supporting documents according to building research establishment. Note number this earthquake. I'm just not telling numbers because this you can read yourself. Earthquake risk in Arabian Peninsula by PEI 1 Central Crastula. So let's go now. On basis of fault and seismic maps present in figure, this area is divided according to above mentioned note into two areas, and they are area 1 and area 2 which damaging earthquakes. An area which damaging earthquakes intensity 7 and above are expected. Area B, an area which although itself is not expected to be subject to damaging earthquakes, yet would be affected by strong distant earthquakes causing intensities of up to 5 and 46. These areas are approximately sketched in figure 3. Special precautions to resist earthquakes would be required in area A, and these would correspond to zone 2 or 3 of Unified Building Code of USA. It can be said that for ordinary well-built structures in area B at which this project lies, design criteria and precautions required would correspond to Zone 1 of Uniform Building Code USA. Based on results of boreholes in project, site area, medium dense to very dense soil materials were encountered. Stiff soil profile, so soil profile type recommended for seismic calculations is SD. Now this is this you can see. This is figure, this is what you call it, number F, yes, figure number 1, major faults in southeast region of Arabian Peninsula. These are major faults. You can see these arrows here. There is project here, this is your project, yeah, this is a project, and here is, you can see this, and this you can see, and then you can see here. So this means major faults in south region of Arabian Peninsula. And we go further, you can see it. Yeah, so there's no explanation for this. And this is actually another indication, and that's important in this giving figure 2 seismicity after seismicity affecting southeast region of Arabian Peninsula. And you can see this magnitude M. This is energy release, you know that, and this is used to log scale. And this Richter scale, you know, this Richter scale. This is less than 5 is this, 5 to 5.9, bigger one, then bigger one, and up to bigger than 8 is this. So these are magnitude M, and which you can see these are replicated here. You can see this one, you can see this one and this one like this. Same way you can go there and see it's the biggest one. There are 5 they have shown. This is this one, big one, and I think if you see other one that is a smaller one than this. I think this is one. I think this number 1, number last one, 5th, and this is 4th, and maybe this is 4th, and somewhere else 3. This is 1, and then maybe 2, like that. You can see means how far it goes to tell you various levels of magnitude expected during the earthquake. In same area there are different levels. You can see 1 here, 2 and 3, and you know at least 3 or 4, maybe possibly 3 certainly in this area. You can see there's a congestion of variation of magnitudes here, and you see in this area there's a localized smaller magnitude. There's a bigger than that, and this is particular area that you can expect something dangerous everywhere because of varying intensity possibilities here. So this is, and here is, you know, it's almost same, and another one you can say has local one is the biggest one here, and same way. So here you can say it's very critical area among this location of 54, 56, 58, and you know these two here which are. So let's go down further. So magnitude smallest shows less than 5, further bigger shows 5 to 5.9, and then this shows 6 to 6.9, some 7 to 7.9, and then greater than 8. Seismicity affecting southeast region of Arabian Peninsula, and this is. Now we go to another one, that is this figure number 3, earthquake area in southeast region of Arabian Peninsula. And this earthquake area they are telling, so which area? Here is project, so here is Abu Dhabi, and here is Abu Dhabi, here is Sharjah, Dubai. Dubai is first, and Sharjah on she, you know, this road is the Sheikh Zayed road, I can say, just parallel to that. This is Abu Dhabi, this is Dubai, this is Sharjah, and this may be Rasul Khema, I think, and maybe, and then you come back to we'll find some Muscat here, and well, this is just the peninsula, means 3 side seas there. So there's project, and this area of, as I think, this area of Abu Dhabi is of course a critical one, as you saw in that report. A and B are written here, A and B, there's something C is written, I don't know it's written a lot, but well, it's just written opposite, so you can say that. These are that. Now we go further. Now this is ground shaking, free field ground acceleration, ground shaking and free field ground acceleration. Intensity of future earthquake ground motion in intensity of future earthquake ground motion in project area. will depend on distance from earthquake epicenter, magnitude of earthquake and soil response characteristics. According to information presented above, tectonics and seismicity of southeast region of Arabian Peninsula, it can be concluded that within anticipated lifetime of project, at least 50 years, let us say they are keeping life cycle 50 years, so let us add 20 more years to that. Maximum probable Richter magnitude future earthquake is 6 at minimum distance of 100 kilometers from project. Approximate maximum free field ground acceleration can then be obtained from curves which show relation between epicentral distance from causative fault, and maximum acceleration for different earthquake magnitudes, such as relationship presented in figure 4. This figure is published in report number 72, Earthquake Injury Research Center, University of California, Berkeley, June 1972. Acceleration in rock for earthquakes in western United States by Bart B. Squirrel and H. Bolton site. Maximum acceleration of 0.06 g was obtained for conditions assumed above, which is considered small value. So potential of substantial stress is considered very, very low. Investigated site is within low seismic hazard zone 1, so ground rupture in this site is unlikely. Liquefaction. Liquefaction we have to understand these points, and I will also like to bring this file here later on. Okay, let us use first. Maybe depending on time, how much I have today. Because already I have broken my time on Facebook ad. It's without giving what to do. I feel really they are too hurry just to start Facebook on new in August, September. I don't know, without being ready. Sorry, let's see how it is. Create our eyes. Liquefaction. Soil liquefaction is a phenomenon in which saturated loose cohesive soils are subject to temporary but essentially total loss of strength induced by severe earthquakes. Significant factors known to affect liquefaction potential of these soils are characteristics of material such as grain size distribution and relative density, initial stresses acting on soils, and characteristics of earthquake such as intensity and duration of ground shaking. Subsurface materials encountered in this site do consist of medium dense to very dense sandy materials, so potential of liquefaction is considered negligible for this site. It's dense sandy material. Now this is the point they are talking of, and let me rotate this view because it's really important. Now, sorry, it was a mistake. I should take otherwise. I should take it otherwise. Clockwise. Yes, it's that. If you see that, this is what is, as y-axis is maximum acceleration g, and that is taken from here 0, 0.1.2.3.4.5.6.7.8. That's on y-axis, and on x-axis is 1, 2, 4, 6, 10, 20, 40, 60, 100, which is a kind of log scale. Average values of maximum acceleration in rock. So distance from causative fault and mile, and there is a just go down. You can see these curves are shown here. You can see these curves. This curve, I'm equal to 5.2, I'm equal to 5.6, and I'm equal to 6.6, equal to 7.6, and equal to 8.5. Now these are curves of various intensities. Let's say 5.2, what it says. Now it says that this point, you can see, when this is 2 kilometers from that location of epicenter, and you can say acceleration is 0.2. While it's at 4 kilometers, it's down again. At 6 is further down, and as far as it goes down, and if you go further down, this means this is the epicenter. It goes this way, increasing distance and decreasing acceleration. Decreasing acceleration. And if we take this curve same as 5.6, distance is more here, and then less distance, less and less. And if you further see, this is M6, all this in this, in all this you can say, when distance increases from epicenter, acceleration decreases. In all these cases is that. Now let's go and see about sorry, again same mistake I did. दिमाग खराब है. Now we are here and we talk of this page. Let's talk this page. Densification. And I think we should put off light. It's not used to understand that put off light. Why do waste light? Strong earthquake, ground shaking could cause densification. That's called densification. Strong earthquake, ground shaking could cause densification of a loose, dry sands, resulting in subsidence of ground surface. This would have negligible effects in more deeply buried structures. However, since site be properly prepared and filled with selected and engineered materials, risk of any structural damage is considered negligible for all types of structures. Collapse potential. Collapse potential says all sites in project area consist of stable sandy materials, which are mainly medium dense to very dense. Therefore, potential of collapse of these materials under structural loading is very slight to non-existent. Now, all soils in project area consist of stable sandy materials which are mainly medium dense to very dense. Therefore, potential of collapse of these materials under structural loading is very slight to non-existent. Swelling and shrinking potential. In view of materials encountered, test results and level of water table, potential for swelling and shrinkage potential is considered negligible. And inspection during foundation excavation. Inspection during foundation excavation. Recommendations given in this project are based on assumptions that subsurface material and conditions do not deviate appreciably from those disclosed in borings. However, there may be conditions penetrating to this site which were not disclosed by investigation due to limited number of boreholes, which therefore could not be taken into account in such cases. Our office will notify immediately after foundation excavation and before foundation construction to accordingly amend our recommendations. We shall do that and confirm that valves with it. Important note. Recommendations and discussions presented in this report are based on subsurface conditions encountered during site work at time of investigation and on result of field and laboratory testing on samples obtained from limited number of boreholes. There may be, however, conditions pertaining to site which have not been in account due to limited number of boreholes. Location of boreholes and trial pits. Yes, here we have to see. I think we have to go back to turn this page, rotate this page. See, this is a rotated page now. You can see this. There is location of boreholes at various places, coordinates wise. Coordinates not given in this, but it's all coordinates wise. You can see here B10 here and B20, BH22, BH2, BH6, BH18, like BH19. TP start, this is test pit. You can say TP is test pit and IBH is borehole. BH17, TP is 6 here, 121, BH13 here and BH14, 23, BH4 and 8, 12, 16 and 20, 21 and TP6. And this is 23, 4, 8, 12, and this is 1, 3, 26, 1, 3, 7, and this is your plant, so we have 24 here. Location of boreholes and trackers, so that was that, and this is your various 51, BH51, 52 and 53, separate one, and 58, 56, 57, 55. Well, now we can say that we have to go to, we will turn on this page again. Logs of borehole and tri-appendix. There are 4 categories in this. This is Appendix B, log of boring and tri-appendix. In this there are 4 sections. Logs of boring and tri-appendix legend, then log of boring, logs of tri-appendix, generalized subsurface profiles. Legend to logs of boring and tri-appendix. Let's see that this very important one. That's this one. Now, let me take some water before I can shot. Let's go this way. Solve is 6. In this you can see legends here. Is how they depict this clay here. Clay, then silt, sand, gravel, cobbles and boulders, peat, fill, crystalline gypsum, chalk, marl, calcernite, chert, mudstone, siltstone, sandstone, shale, basalt, phosphate. Sampler type. Three-cone, that is, you can say, this sampler type is related to simple, this one's sampler type is related to this one. When you use tricone means disturbed for disturbed one. Cone barrel relatively undisturbed, and auger is disturbed. Then shell bite tube is for undisturbed, and dry cylinder that is for manual relatively undisturbed. Then dry barrel, which is relatively undisturbed, dry barrel. And dry split spoon, and that is SPT, disturbed. SPT grows per 30 centimeters square, which says that Number of blows in standard penetration test. Required to drive a 5 centimeter. So number of blows is 1 point. Required to drive 5 centimeters diameter. Split tube, 64 gram weight. So you can say here number of blows in this test required to drive a 5 centimeter diameter split tube, distance of 30 centimeter, distance of 30 centimeters using 63.5 kilogram weight falling to legs, falling into that one. Falling 76 centimeters. So height of this is 76 centimeters, weight is 63.5 kilogram. That's 1 point here. Means this is 1.63.5 kilogram and 76 centimeter height. That falls to penetrate 30 centimeter. To penetrate 30 centimeter, how many number of blows required? That's there. Now, what you say? There are two types. One is fine grained soils, one is coarse grained soils. And it's giving here some information on that. So this is fine grained soil, and this is, you can say, what these say. You have to understand this in this table. This table is very clear. On one hand is fine grained soil, and other hand is coarse grained soil. And how they differ together, this is given. Just like this, and legging on like this, coming back. So, see what to do with this. Let's do with this again. Let me see how is this working. Cut loss of it on. Really with that, So it's still going on. Yes, this is still going on. Right. So fine grained soils, what time was there? Let me see, I want to see time. This time is 46 minutes, so we have no problem. It's okay. SPD blows 37. Now this is a standard table which gives you, I think you know it probably. Means in fine grained soil these are parameters valid, and in coarse grained soil these are valid. In fine grained soils means like you can say sand soils, fine sand soils and silt or whatever it is, you can say in that case, which are very fine. If SPT blows per 30 centimeter is say 0 to 2, consistency of soil is very soft, because only 2 times you apply that force. You 2 blows, just it's very soft distance, it fills there. Then easily penetrated several centimeters with fist. You know this fist. With fist you can penetrate that. Unconfined compressive strength kilogram per centimeter square is less than 0.25 kilogram per centimeter square. It's very small. I'm talking of this only. I'm not talking the other one. Now first let us finish this and we talk of. Now if there's 2 to 4 blows for such soil is soft, easily penetrated several centimeters with thumb. Previous class is fist. Fist means this, and thumb means in like a concentration. This 0.25 to 0.5. And when it is 4.8, 4 to 8, not 4.8, 4 to 8, it's a firm one. You can say firm, little better. Means it's firm and penetrated several centimeters by thumb and moderate effort, and it can take 0.5 to 1. The previous version 0.25 to 0.5, 0.5 to 1. And it's 8.8 to 1.4, 8 to 15 is a stiff, readily indented by thumb, but penetrated only with great effort. And it is 1 to 2 its strength kilogram per centimeter square. Now it is 15 to 30 blows, which is very stiff, readily indented by thumbnail. So this is 2 to 4, and then if it is greater than 30, it's hard, indented by difficulty by thumbnail. So, and it's greater than 4. So this is regarding fine soils. Grained soils, fine grained soils, loose sand you may say. Very fine sand, loose sand, dense sand, or how do you say? Alright, now we go to coarse grained soils. Now blow same per 30 centimeter, and let us say 0 to 4, which is very loose. Means it is about double to that. 0 to 4, see, 0 to 4, 0 to 2, 0 to 4. 2 to 4, 4 to 10, so it's more. 4 to 8 and 10 to 30 इसमें It's 2.5 times. And no, last one more. 30. Then you can say 8 to 15, 32, 15 is much more than even double. Approximately this is around 3.5 times, and 15 to 30 is greater than 50. So there's a lot of difference in that. Let's say. So when it's first case, the 0 to 4, it's very loose, I can say. Where is that? Very loose, easily indented with finger, thumb or first. And relative density is 0 to. Now, if you say 0 to 4, very loose, easily indented with a finger, thumb or nail, and its strength is 0 to 20, 0 to 20, you can say density. Its density is not strength. Strength was considered as density is same, and then it's for coarse grain soils. Then 4 to 10 is loose, and this is 4 to 10 loose. Now 4 to 6 loose, that was very loose previously, less easily indented with fist, but easily sharpened, and its density is 20, 40. Then 10, 30, medium dense, and it's then you can say 10 to 30, medium one, medium dense and sharpened with difficulty, 40 to 60 density, and percentage, it's relative density percentage. Relative density. Then you can say 30 to 50 required, dense and required quick to loosen or showing with the hand. 60 to 80. And then greater than 50, it's very dense, requires blasting or heavy equipment. Now, what it says, let's go further. What is functions of this in our life? That's more important for interpretation of this report. Recovery. What is recovery? Percentage of length of core recovered in each run to total length of core run. That is recovery. Percentage of recovery is how much total you have withdrawn and what is intact in that. That's called recovery. Means more recovery means better soil. Less recovery means not. What is RQD? Rock quality designation. This is percentage of sum of lengths of intact core pieces 10 centimeters or larger. Length of recovery of quality designation RQD is percentage of sum of lengths. Sum of lengths of intact core pieces 10 centimeters or longer. 10 centimeters or longer to total length of core. Let us say like this better. It's sort like good, it's sort. So that is RQD. Your quality designation is percentage of sum of lengths of intact core pieces 10 centimeters or longer to total length of core length. Means percentage sum of lengths of intact core pieces 10 centimeters or stronger or longer to be now when you say that percentage of sum of length of core pieces 10 centimeters or longer is called total quality. What else? Alright, 10 centimeter more pieces got intact. That's called a quality designation. Percentage of sum of lengths of intact core pieces 10 centimeters or more or longer is total length of core. Load strength and unconfined compressive strength. Load strength and unconfined compressive strength. In point load test, rock core is loaded between two steel columns. As before this, I like to show you something else also, or I forgot otherwise. Let me show you some cut pieces, or you can say extracted pieces of soil. Well, I think that will be better for you. Just a minute, please. Let me go to this and see if it can work for me. Journal records, persistence. Let's see if it can work for us, so that maybe. Well, I don't use that one. I like this or something. I don't think it's that one. Then we say, I'll open other one, and not this one, this other one. I think I should take, which one I should take? This was 2, now go to 3. That's what 3 says. I think it's not going the way on which I wanted, so I know that also. Yes, it is there. See, this is also one sample, but you can see this is more than 10 centimeter. This is maybe more than 6 So you can say this one is, I think you can understand what I mean, or get lost here. I think you get my point. What I'm saying is, these are not there, possibly, maybe this one and this one is more than 10 years. You can see this one size and this one size like that. You should get pieces like that. And also you can see this one is like this. There should be such pieces, such small pieces, won't add to that one. This piece is more than 11. The core economy. More than that. And if you go further, same thing, you can see this piece, and this piece. And if you go down, same thing, the many pieces here, this. Then you can go to the further one, and that is here. You can see this one, and go to the further one. There are such pieces. These are intact pieces. You can consider those probably. I don't think it's started yet. Similarly, in this case, you will find this piece longer, this piece longer. Not these, you may well see about 60% are, in this case, 60 to 70% longer pieces. And here almost all, you can see this, almost all are longer pieces. So RQ is higher in this case than the previous case. You can see almost 90% are longer in such case. Then when we go to same here, you can see there's 10% probably not very well. So in this case also better arrangements, much better than previous one. Now if you go further about understanding RQD, you'll find that. See here, small pieces are there, but longer also there. So this is also worth RQD. And you see, this is maybe 50-50 or 55-45. 55 longer and others not longer. And here you see clusters, so maybe 45-45. This guys we can see. Now in this case RQ is lesser than previous one, and here you see recovery is nil. Recovery is equal to nil. Only 2 pieces. This is a better case than before, you can say, much better. Here you see long pieces, except 1 or 2 more, I think. It's maybe 95% recovery, 95%. And this is also better. Then we can say another one. This see very bad here, nothing is very good. And this is also not excellent one. 40. And also this is not encouraging as well, so it may be 44, 45, 60. Yeah. See, it's not very well. Now I'll show you. It's still 50-50 or 45-50. You see, very bad here. May have 25. See, 25. Or it's just to see. So you can associate some now also longer. It's better than before, maybe 70% in this case. It may be much better. So this is like means 30, 40, 60. It's also very not good like this. Now we go to see, it's very bad, you don't see that. It's very bad. It's also not very good. So we have to, based on these photographs, we could learn something. I understand. We got my point, and now we're back onto our reporting system, and that's it. That's what I say. It's here now. So we got value of this. Now we are talking this artery road quality designation, percentage of sum of length or depth. In this case, we can say now it's only, we say load strength and unconfined compressive strength. We will discuss this, and we have to go by, I think we have to see this load strength and unconfined compressive strength. Load strength and unconfined compressive strengths. Before going this, I'll have to see if there's some more file I can use for you people, something in that. No. Well, in soil, I had something with you before. Again, power has gone. Power has gone. No problem. I don't think there is something in this in that way. Okay, now what to do? Log quality, log strength. I will discuss log supporting. Point load. यार क्या करूँ मैं इसका? In point load test, a rock core is loaded. A rock core is loaded between two steel cones. Between two steel cones, a rock core is loaded. And failure occurs by tensile splitting. Two steel cones and failure occurs by tensile splitting. Now a point load strength index Fs in this point load test, a rock core is loaded between two steel cores. Then a point load strength index LFS, point load index, strength index Fs is calculated as ratio of blind load P at rupture to secondary effect. Of course, a point load, strength, let's just say, a point load strength tax index Fs calculated as ratio of applied load P at structure up to square of distance h between load points Fx is P over h square. That is, P is of course load and applied load, and h is between two load points, that's distance. A correlation that's commonly used between point load index and unconfined compressive strength. This is delta G. So delta Fu of cylinder with a length of diameter ratio 2 to 1, length is 2 and diameter ratio 1, Qu is equal to 24 yes 50. Now where is 50 still so 5 strength we have to see. What you see is that a correlation that is commonly used between 2 points, and that is a 2 to 1 and 24, and whereas 50 is point load strength corrected to diameter 50 mm brook and frequency. So what it says actually, rock quality is, let us say, rock quality designation is 0 to 25. It's very poor. There's rock quality and rock strength, 2 points that we are talking. Let's talk first rock quality. We are talking rock quality. Rock quality, we talking here, and because there is no light now, it's a problem for me. The light is not available, and always there's a danger of something hands off. So let me just sit comfortably and rock quality, let us say. Rock quality, the designation, RQD, and rock quality description. Rock quality, crack strength, let's say. Rock quality designation RQD is percentage 0 to 25, 25 to 50, 50 to 70, 70 to 90, 90 to 100. I have shown you various scores. I have shown you those, and I understand you get them better. And I am closing one of those files, and you get this. And then it's 0 to 25. And 0 to 25 is very poor, and 25 to 50 means I'm talking of those course recoveries. 25 to 50 means we're 10 centimeter more we count into our recovery, and if you get, so these percentages are from there. 25 to 50 is poor, and 50 to 70 is fair, 70 to 90 is good, and 90 to 100 is excellent. See, we got many which are from fair, good, and excellent. Excellent for very few, good were also very few, fair were many. And we can say now that and rock strength, if you can say rock strength here, description is the same, very weak, say it's very weak, weak, moderately weak, moderately strong, strong, and very strong. This case, point load strength as you see above for 50 mm diameter sample, and that's LSO 50 kilogram per centimeter 0. This is less than 0.5 kilogram per centimeter square, 0.5 to 2 kilogram per centimeter square. And this is very weak is this, weak is this. Moderately weak is 2.2 to 5, and moderately strong is 5 to 20, strong is 20 to 40 kilogram per centimeter square, and very strong is greater than 40 kilogram per centimeter square. You know, when you say very strong, say greater than 40 is strong centimeter square kilogram per square. You remember when you use concrete 1 to 4 in those days, around M15 concrete, which we say acceptable strength is 50 kilogram per centimeter square. So here is 40 kilogram per centimeter. So you can say you may say somewhere M10 concrete could be M10 or 12 or 13 like that. So this was point load strength. Unconfined compressive strength is then, in this case, this was unconfined compressive strength is in very weak, less than 12.5 kilogram centimeter square, and weak is 12.5 to 50, as is given here. It's given here rightly that very weak it is unconfined compressive strength kilogram less than 12.5, and weak is 12.5 to 50. Moderate weak is 150, and moderately strong is 125. Strong is 50 to 1000, and very strong is greater than 1000. So there is a vast difference. There is application of point load and there is application of unconfined compressible strength. There is a point load, a lot of difference. A lot. Greater than 1000 even. In this case, very strong rock, very strong. So this is what is, rock strength and rock quality. So this was point load strength and unconfined compressive strength. It said in point load test, a rock core is loaded between two steel cones, and failure occurs by tensile spreading. This tensile force on there. Tensile. And this is almost compressive, Just a point load strength index is calculated as ratio of applied load at rupture to square of distance h between the points P over h square. So P over h square, that is, and whatever force is there is height there, see, that's P over h square, and that we got here. A correlation that's commonly used between point load index and unconfined compressive strength Q, of a cylinder, that is, confined compressive strength. So with this length diameter ratio 2:1, 75 is whereas 50, whereas 50 is point load strength corrected to a diameter 50. Okay, now let's go. This was for tensile strength. That's also right. Can go to that. Logs of boring, and this is, you can say, long one. Logs of boring. We'll discuss this one, but now we jump on. We would like to close this. Let me go to, before I go to contracts. Now, contracts also very important in our life. So I like to discuss contract now. FIDIC, because let us say that I'll close this file. We'll take it tomorrow because everything is required and we can discuss now. Contracts. Alright. Let's stop this. Now we had gone through last time on this FIDIC, and where we got, I don't know exactly where we have gone, and we go back and down. I think we have done some machines, etc. That's where done. That will not take long to let it down. The contractor is gone. This is start. I was there. Design has gone. Training, facility course, site for labor, trans materials, commencement delays and suspension. 7 to 8. Yes, I think commencement delays and suspension. This is what we have to start with now. I will start commencement delays and suspension here, and I think I should blow it up better. Yes. Commencement delay and suspension. FIDIC 2017 silver. I'm continuing that. Maybe you people are not that much interested, but this is not question of interest. Question is requirement, and requirement is also important, very important. And if you people don't understand requirement, this means we lose something everywhere. Without contract, practically nobody works. This point you must understand. And when there's requirement, there's no question of option. It's up to individual in profession what level 2 you want to move. If you want to stick to only discipline in your profession, For example, if you know I am only inclined in designs, or I am only inclined to work on site, or I am only inclined to work in planning, or I am only inclined to work in quality, like that, if you think, I don't understand in that case how can you make yourself a better professional. Shall you like to work whole your life into that? Let's say a life career for more than 40 years. Shall you like to work only in that section or in that discipline for 40 or more years? I don't think that's a sensible answer. Then you cannot say that you are professional all rounder in that case. Okay, that's also very important part. But if you participate in other disciplines, I mean this is that professional discipline which is related to your profession, it's better for your personality development and it's better for projects as well. Because if you have, I think, 2 or 3 or more specialties in one engineering discipline, it makes one a better professional, and rather shunting yourself only to one discipline. Say, no, I am only on site, I don't want to come off site, I don't want to work in office, I don't want to design. No, I don't think this is the right attitude. Because you have to serve public, whether it's directly or indirectly, it doesn't matter. Whether you work with contracting company, or you work with design company, or you work with employers company, or work where you want, or you work freelancer, you have to serve public. And public has every right to extract your specialty, and you have every duty to submit your service to them. And if you are multidisciplined in same branch of engineering, you can serve better. Because understanding of design is very important. Simultaneously, understanding of practical activities are equally important. We cannot keep design and work site in isolation. They have to move together. We can keep everything on paper together, say BIM, or let us say building management system, or we like to keep everything coordinate itself, but we don't want to involve ourselves. We want information from software. That's where we lose our ground. There was a time when personal involvement was more important than these papers. Means everybody used to know what was done that time in that area. Now it's missing, actually. It's missing. And that's a point of concern. That's a concern there we should think of. And thinking of is only answer to every critical problem. Thinking of. And if you cannot think of, certainly you do something irrelevant, you do something not acceptable. That's only purpose that I only suggest, I don't want to direct or force someone. Only suggest that profession requires multi-status knowledge, multitude of knowledge of some limit which allows you to work in that field. But it's individual attitude, I can't say that. If you do not understand quantification, if you do not understand design, and if you don't understand something else, site procedure, site activities, then you can never say that I did that project from initiation to delivery. There your point of weakness lies. And you may claim that you are certainly that engineer, but internally you have missed a lot. You have missed a lot. One misses a lot. You should not miss. I just wanted to say that because of some reason, and I think as an experienced person, it's better for everybody to learn something which you can't learn in university. I got some message from one of my colleagues, though that colleague missed later on, that there are so many topics, so many subjects that are not covered in universities within 4.5 years or 4 years of engineering time schedule, engineering education time schedule. Our students, our engineers are not well aware of, say, what is contract, what is constitution of this country, what is contract act, and what are other procedures related to contracts. I see these are very basic points, very basic issues. Don't forget that if you are a design engineer, you are also required to have some service contract with someone. And if you are asked to draw that, can you draw that? That's the point. If you are asked to draw something of a small building contract or a contractor, can you do that? And if you can do that, fine, that's okay. If you cannot do that, why don't you do that? It's your field, it's your line, it's your knowledge, it's your efforts. You think you need advocate for that? No, I don't prefer that. Because advocate does not understand our field, and they will just put in complexities into contracts rather than solving problems. We don't want complexities. We want good relation with clients, working good working relations, pleasing relations, relations that take both parties. Both parties means contractors and owner to certain level where they both feel satisfied that I paid this much amount to this contractor and that contractor delivered to me a good building or good structure. That's the only purpose of contract. There's no other purpose. Of course, I know engineer is not involved in that contract directly, but involved or not involved, you have a responsibility there. You have a responsibility of technical work, engineering work, as well as administration of contract, and you may not understand that, you may not like to hear that administration of contract, but world doesn't move because what do you think? World moves to what is done and what's required. You might have seen my posting or may see I made some posting. Of course, it's not nothing new. There is always contract dispute, you know that. Always you'll find contract disputes everywhere in construction projects. It may be civil construction project or it may be other disciplines, other branches of engineering, say power station machinery and power station civil works and power light, or some facilities. You shall find all kinds of payment disputes or some other disputes on mega projects where some decision is required, judgment is required, and court is not competent to deliver judgments on that. So there is a law in every country, all over the world, that because judiciary is not competent on that line, they are not experts, you can say. This judiciary in every country which we have, there's journalism, journalist judiciary, court of ordinary jurisdiction we call it. And this is not ordinary work, engineering contract or engineering construction. This is not simple construction. This is called engineering construction, where engineering is involved in depth and in full and not superficially, uniformly and severely. Full potential is actually there. Contractor expects profits only, that we understand. And that's not bad also. Contractor has every right to make money. But I'm not against contractors making money. I am against what contractor doesn't want to do. or what contractor wants to escape, and we have to set that right. This means if you want a project to be delivered with quality and with, can say, value added to everything, so that whatever design was done, approved by client or owner, that must be constructed, that must be made and delivered to that owner with all inclusions of, good inclusions of quality, safety and designs. Designer is there in that involved, but not dedicated on site, but his drawings, designer's drawings, specifications. I will not just simply say designs, I would say specifications as well. And methods, of course, all these designs thought go to site. Designers may not go, but designer has a responsibility to have made sure that designs submitted, design issued by that professional engineer must be done truly and in compliance with laws and specifications, with contract conditions in each and every respect. And that is possible only when there is a good alignment between site team and design team. You cannot just keep your boxes, your drawings into Almira and sleep that site guy shall take care. Simply answering when some question comes that talk to site people, this is not our business. That's not right answer. That's not right answer. Somebody has to respond. You have to respond. And that's where I say response and response and response and working on site, and that's permission or that's approvals on site for everything are very important. That's why we miss sometimes, we don't teach people what is contract, what is inspection, how to inspect, and what precaution you should take, what points are required. We don't open books of designs there, no. We just try to teach them what is right, what is not right. That point is really very important. Now, it's the responsibility of every design engineer that one should be with team whenever required. Of course, financial matter exists, fees questions are there, that is separate point of view. Considering that exists, reliance on what's it is your duty as a design engineer or that you have to take care of work on site as far as supervision or inspections are concerned. If you don't do that, you miss something you should not have missed. This point is not clear to many that you can't expect design, you can't expect site engineer to understand everything what you have produced to be complied with, and that quality is not your responsibility. Keep out of your mind. Quality is certainly your responsibility. Yes, quality guys there, I know. Quality guys from contractor will be there. Quality guy from designer should be there, and if not there, must be there. Because what was in mind of designer, quality guy cannot conceal that. What was in mind of designer, site guy cannot conceal that. You have to streamline that work before all works are done. You have to streamline what way site, how site they should done, what method they should apply. Same thing, you have to streamline activities of quality guy, means what you expect him to inspect. And same way, all other safety disciplines, all other things, and here we are concerned with quality first. Quality first, although there is a safety first is there, quality first can be there. everything will be first. And first doesn't mean you are smart, you can do anything. Now we have to say FIDIC. I'm just explaining to encourage you people that you can become arbitrator, you can help disputing parties by consultancy of contracts because you are good in contract. Arbitrator, of course, there are so many sections in arbitration, and there are arbitration for many disciplines, but where engineers are concerned, we are concerned with arbitration of our disciplinary works and what our contract says. That works both can go to arbitration without even knowing further the conditions of contract of important. If there is a condition in contract that arbitration shall be referred to, this means that you have to know other way. Must be. Arbitration is always separately done before also separately done. Now let's go to FIDIC for 2017 Silver, where I left that on Article 8. I talked at end also of cover up what we have done. Now let's say what we're talking here is okay, we are talking here is now we're talking commencement, delays and suspension. This Article 8.1. Commencement of work. This is really something we can say. I'll give you 150. Let's commencement of works. Commencement of works. Unless commencement date is stated in contract. No. Unless commencement date is stated in contract agreement, employer shall give notice to contractor stating commencement date not less than 14 days before commencement date. I will say commencement of what? Better I did use this, I think it is not working. Not working correctly, let's see my 14 years. Alright. Commencement of works. Every project has certain dates. Every project. And those dates are necessary, essential. Not because clause says that, not because the FIDIC says that, it's common sense that your project means it should start and it should finish. This is very common sense. It's like that. You have to take date of birth, and one day you have to say date of departure. These points are very clear and must be understood. When we say project, what do you mean by project? You have to raise a question yourself. Can you define what's a project? Can somebody define what's project? You are an engineer. It's your duty to talk to yourself what is project. You don't need somebody to tell you what is project. Do you need someone to tell you what is project? You need none. Because project is very common term. If you ask someone's project, this is my project. They don't know what is project, but they say this is my project. You talk to some shopkeeper, you talk to some professor, someone. For them, this is a project. Every activity is project for them. That's what I say. Only engineers understand what is project. No one else. You are just writing a book and says my project. Is it? Never. Because there is no start date of book and there is no end date of book. Say, you are doing some work in your university. Oh, this is my project. What is your project? This is my project. My thesis is my project. Your thesis is your project. Okay, you consider project, no problem. After project, what shall it be? See, project is a goal. Understand? I'm talking different way. I'm not talking what people talk, what professors talk. Project is a different way. Once project is finished, once project is cleared, it's done. Where is it then? Where does it go to? Can you answer? Where does it go? It doesn't go to anywhere. It should go. That's what I'm saying. That's what I'm saying. Project means you start something and you finish that thing, and then it should continue in that status to disseminate this information to others. Complete it and let it come into operation, because that's what project is. When we say project, we have to define dates. We have to define 2 dates particularly. Date of start or date of commencement and date of completion. These are must in project. Where we will find which one we are going to start with. These points you must understand. If there is no commencement date and there is no completion date, it can't be called a project. It can't be called. This means it's open at both ends. There is no guarantee of that. No guarantee of that. I remember one incident. I joined one BPC, management BPC, of one organization just for one assignment. And there was some problem on that project regarding date of completion. When, say, I was in a meeting. I was in a meeting with that company, with contracting company, and of course with one client, that project engineer of that. We had some problem. We had to discuss with both of them, not one. Our duty was to report status of those. Okay, I was just leading. We arranged them. We arranged for us tea, refreshment, and what is called. This was our station project. There are many issues on that project. Many issues. No problem. There are issues. They are required to solve those issues. And those issues cannot be taken for granted. It must be done. But what were those issues? That's the point here. That project was not starting. It was in between, and actually it was such advanced in days, not in progress. In days it was such advanced actually that there was already bypassed the contract completion. I did not know that. I just said a nigger comes to the ocean. Now on that project, what I saw when he started building, I asked that contractor's head there, who was head or agent or whatever you call, I don't know, representative. Shall you tell me when you are going to deliver this project finally? Do you understand my question? I asked him, when shall you deliver this contract? That representative or agent of contractor answered in that meeting, I don't know. What was answered? I don't know. We don't know. Well, I could not understand what nonsense he was talking. What do you mean you don't know? I asked you, what do you mean you don't know? You are contracting, you are working. He said, yes, we are contracting, we are working. But our contract completion date is in past now, history. Do you know? Completion date is already expired. Well, really speaking, I was surprised. What do you mean by that? Yes, what does it mean? This is mean by us. We have no idea when this process will complete. Because we have already crossed the date of completion. Then I said, why are you on site? If you are not contracted, it's okay, I'll stop from tomorrow. Because your client, this party, employer, we have written to them various reasons. We have applied for extension of time, EOT. We explained to them, we sent them the reminders, So far, there is no decision on that. There is no decision on that. So what can we do? Then those party people start saying, no, we have done this. No. Give me letter in writing that you are rejecting extension or you are granting extension. Only after getting that answer, we shall respond to you. And we can start from, no problem for us. I will start from tomorrow. I told him, show me a clause where it's written in this contract that you have authority unilaterally say on such kind of a job. So that was a very good point, when I asked project engineer who called me, what we are doing here. If that man doesn't consider anything for project, that person doesn't respond to us, what for we are sitting here? I told him I cannot participate in this meeting, and project engineer also accepted that we should not participate. Yet to go to that, to take me to that comment people. But I said, what for? Here problem is not meeting with government people. Wow, it is meeting but fulfilling, pending out. This happens, if you don't have anything, you don't have any contractual values, you don't want to maintain contracts, you just want to write something and say, okay, let it go, so there's no one responsible in that department to decide what is fault of contract. Yes, that's another fault that we've done somewhere. That is the same. If that one I've done the other side, which says same thing. Here, these people agree what they say. They do not want to solve any problem. So what I will say is, if there is no contract completion date, but there is only start date, you don't know duration of contract, or is there a duration for no meeting, and you need another duration. Otherwise, how can you say this much work is done? When you see, sometimes we have to impose damages on delays which cause havoc on contracting company. That delay is not pleasing one, but very, you can say nobody wants those delays and those penalties or damages. Nobody wants them, but it happens, because we should not forget that profit element is not very wide on contracting. Responsibilities are more than that. But it's fault on both sides. Because of that, there is a cost. There are many reasons, and those reasons should be solved from time to time legally. For example, say land was not given in time. Is this fault of contractor? It's not fault of contractor. It's fault of client. Land was not issued in time, or there was some other legal requirement which client was required to do or owner was required to do, could not be affected accordingly. There are so many questions, so many issues under contract that lead to external works, external public works, where even client refuse some people. See, per day damage imposition is very easy, but control of works is not easy. When I am talking of commencement delays and suspension articles of laws, we have to think at that time that you cannot simply say, I am attack contractor, contractual. Question of attack does not arise. Don't forget, there is only one goal between employer and contractor, and that goal is that we have to finish this project in time. If you go with contract things, you are supposed. When we say commencement, always there is a delay in commencement. Why? There is always delay in commencement. This has been usually observed on major projects, particularly on EPC and also on construction projects. There is no difference. You talk of red book, you talk of silver book. This problem lies everywhere, because neither owner is prepared nor contractor is prepared to bring them to some level from where they can move forward. I am not talking of competition here. Delay in start is very, very critical. In that sense, first of all, mobilization is to be done. Mobilization is to be done. Which contractor may be not having that sufficient labor workers, and whatever activities are involved in mobilization. Previously it was one week time, 2 week time, that's all. This, in beginning, people are careless. Oh, we have 2 years, we'll finish. We have 2.5 years, we'll finish. They do not analyze contract. Missing analysis of contract is based on both parts of parties. Employer saying, oh, I have given plenty of time to this contract that it should happen. But nobody goes into details of contract. Nobody goes there. So you say, okay, fine, you will say start this project without any you will share back date. That's also it is some places. You finish project say in your time and will show back date. That is also a problem here. Some departments do that. Indirect favoritism in their director has to get this way. That's why I say sometimes we have to understand these points very well. I'm doing this project not because I want to teach you. I want to just establish what we should do, what we should not do. And remember, without contracts, your project cannot finish, your designs cannot work. It's very important that we should understand contract very thoroughly, such that we have to so never thought of this. It's a litigation or something. It is impact or savings. No, actually, contract is very complex in such situations when contract clauses are, impactful. When we say contract, it's not simply commercial contract. It's not simply part of that price. That price is a consideration. Means because there is a price, that makes it a contract. And if price is not included, then that's the right or something. When we say contract, it means contract domain which comprises of technical domain, work side domain, and side domain. Contract includes production, contract includes all activities, and contract includes designs, contract includes quality, contract includes safety management, contract includes planning, and contract includes everything. Consider from day off. And then from day off. When something starts, that point you must understand clearly that contract cannot be taken in isolation. No way. It has to be taken in consolidation. consider every contract on similar pattern, on similar seriousness, that compaction should be done correctly so that density is higher as much as possible. It should not sink, and in fact it should lead to good consolidation in future if it is non-granular material. It should continue. That's what we consider in our studies, or in our, we can say, walks of life. We consider that. We consider quality of every item and everywhere in all activities. We consider timings, and we consider safety of every every element, every component, vertical component or horizontal component. Contract comprises all that. It's not simply a document that you can simply say, oh, this is contract. No. Everything that you do on a site or on a project or on designs, all refers to as constituent part, as a part of your contract. Every activity that you conduct or carry out, every material that you procure, every safety measure that you resort to, every technical matter that you do, every design page that you prepare, everything that we do on sites or does, or else whatever, all are covered under scope of contract. But we do not realize that. We do not realize that. And that's why commencement, delay and suspension always come in if you do not go. Client is not sure, employer is not sure. He includes something in the contract, but he does not know that. Whether or not that is going to happen. If it is unforeseen, include in contract. Why don't you? We'll see later on. No, you cannot see later on. You cannot see later on. You are going to play with contract, and therefore you are going to tell someone else financially, as well as you are going to pull yourself into that dispute which is not expected on contract, but because of your behavior, because of your carelessness, contract becomes a ditch. Do you want that? If you are not sure, today you say this item is included in this contract, but later on, then you failed to get that item into contract to say, okay, we don't want this item. We suspend this. Why do you suspend this? Why did you bring that into contract? If you're not 100% ready with that, you had no plan, and therefore you put other party into a ditch. Right? It's very serious issues. This is not insurance contract. This is not travel contract. This is not something you buy or hire, rent hire contract. This is not 1 day contract. This is not 2 days contract. And not even, this is whole duration contract plus warranties, plus maintenance, all that. Warranties also amount a lot. It amounts many years, many times of duration of contract years. Warranties. But why should there be disputes? A question. Disputes are by bad intention, not by good intention. Don't include something in contract which you are sure you cannot do it, or you are taking by chance. No, don't take chance. If you take chance, then you have to pay. Remember, if you take chance, you have to pay. This is life. No way you can be out of that. You can't be out of that. If you take a chance, you are required to pay for that. You cannot play with those who work for you. They are not your slaves, they are not your servants. They are equal to you because you are on contract. This is not employment service contract. This is production contract. This is contract of design. This is contract where professionalism act. It's professional contract where lot of thoughts have been applied, lot of theories have been applied, where everything is applied. So we cannot take contract for granted. And if those people who take contract for granted, they have to pay for that. They have to involve themselves in that. And if we can't do that, if we can't understand that, then there is no way that you jump onto that contract. Why I am telling all this? Because I know what happens when contracts are drawn, when designs are done, because everybody wants to meet its own targets, and to meet own targets you want to disturb others. Just because you want to meet your target, you keep others at your leg and kick on papers. Okay, we do it now, later on we will see. And that is where problem lies. That is where problem lies. That is where we are not sure. Designer is sometimes not sure what method shall be employed for this design to carry out, but they design. Or whether that type of equipment is available in market that is required for this. No, they do not know what they design. And sometimes contractor also doesn't know what method shall be applied for this, what actually status of material is, but he accepts. Means just to grab opportunity and to see later on how to fight with those problems, which creates problems for everybody. Which I am talking to you is very serious issue, because chapter is that commencement, delays and suspension. When it is a commencement, okay, commencement is fine, but if it's a delay, that's not acceptable, and if it's suspension, that's also not acceptable. Generally, question of overrun of time is raised in many academical interviews, in many professional titling interviews, or there's a time runoff, there's a run out contest, running of time. How will you handle that? So my question is, my cross question remains, why shall time run off? Why? Question is that unless there is unforeseen, unless there is force measures, why there is some delay? Delay is not admitted. I do not admit delay as a professional, because delay means there is some incomplete preparation, incomplete input to contract, and that's why there is delay. There is no other reason of delay. It's very serious issue, because all these inactions or lack of maturity in profession haphazard nature of thinking, just thinking for self. Though on contract there are both parties and each party thinks its way. Well, contract is not involved at that time. When you do documentation work, when you do design work, when you do something else, no contractor exists there. I cannot say that it's fault of contractor. It's fault of that people who are responsible for that. So I do not pinch in at this time to contractor, because contractor comes at late stage when everything has been done, every document is ready, and you have made so much documentation, you've done so much work on documents and drawings that it's not practically feasible for a contractor to comprehend whatever you have done in these documentations, particularly when it's a mega project. Intentionally, care is not taken in those organizations who are in field of working out contract, carrying out contract. Now, it's not a general material. It's not general but very specific one that I'm telling you. And I'm telling you very seriously, because what I observed in my life is actually unjustification cost to all contracts. And when we say EPC particularly, well, in construction contract, you guess it's the by design and you take your responsibility. So their contract is still safe, little safe. But in EPC, it's different. Contractor has to share your responsibilities. You are just to supervise and enjoy your project, while contractor has to do what you are doing, maintenance, temporary. That's what contractor is required to do. And if contractor cannot do that, if contractor fails, it's not because contractor fails, it's that engineer fails, it's that owner fails, it's that, designer fails. In fact, I should say designer fails. Because it's not simply EPC that you have no design work, you are also a designer. Yes, EPC will design based on your feedback, based on your feed, based on your input. There's a tendency to leave every outstanding work which is a mandatory to be done at time. That when we fail, we lost it. That's my concentration on thinking on contract. You may have seen, or you might see many people in contract, and many people like to see they are also not finding which is best one. Well, I'm not going to discourage public and your people on this issue. My simple confinement is that commencement and completion, which are defined on contract for certain consideration, must be evaluated properly, weighed properly, and the sources. There is no reason that we should be extraordinarily affected if everything is fine. It's question of years that both parties have to work together, and they have used resource. They have to use money, and use materials, and defined sequence, and well, I'm not I've not explained it further in commencement delays and suspension because I wanted to alert everybody. This is very, very strong, powerful article of clause 8.1 or 8 you can say, clause 8, which is here 8.1 in terms of that. Before it was royalties is gone. So in this commencement of works, then time of completion, then program, and then you can say advance warning, and after that extension of time for completion, and then delays caused by authorities, rate of payments, then delays, damages, and then you can say employers suspension, and you can say that consequences of employer suspension, payment for plant and material after employer suspension, and then prolonged suspension, resumption of works, and then tests and completions next chapter. So in this we will discuss these very important articles or clauses we call them this contact is very long EPC, and parties who take this contract who can tell should not be told, should be well understood in a professional way, and every attempt should be made to avoid disputes at every cost, because aim of engineer is not disputes but to resolve disputes. Aim and result is right. Something can be suspended or something cannot be suspended. Something can be terminated, something cannot be terminated. Now, because I say contract, and to be successful on contracting, we have to be successful professional, successful engineer, and you know that wherever there is a dispute on contract, what is to be done is that first engineer, so-called engineer, or independent of both parties, this person, contractual person, authorized person, who is legally as well as professionally required to resolve disputes between two parties. Instantaneous person that can. Then you can say that whatever is done, it's okay, fine. We can say that whatever is done is done. And I'll see that next time when we meet, we'll talk a lot on this issue, though this issue is very big and you can talk many days for this. I don't know how to do that because my approach is to understand and let you understand this. Many of you are engineers or contractors maybe. Many of you are dealing with contracts, dealing with billings or relations or quantifications or designs or planning, safety or quality. Those points are very important, without which world cannot move. Those are very, very important, and if you can't understand them, if you don't want to resolve problems but create problems, then we can say that we are not very good quality engineers. Minimum dispute, least disputes, and best quality, and best planning, and best safety. This approach we should have rather than tolerance and tolerance and tolerance. No safety, no quality, no proficiency in contracts, no proficiency in bugs. So we should not be in that state. We should not stay on that bridge. Where there is no quality, we stand there as wrong. Where there is no planning, we stand as wrong. Where there is no you can say safety, we stand on that as wrong. And there's this resolution, and there's those resolution. Nobody can say this way, not this solution. Everybody is this way. Just can say simply, just to divert yourself on something. Now I would like to close it because it's already late, and today I missed a lot because my first video was to be changed. Some Facebook was not ready, and I had to change that. And I think there's some problem, and I tried to share these documents, and I understand if I share these documents, I do better talk to you. I can talk to you in a professional way with clarity to you, and you can also raise questions to me. If not during talk, you can write on my mail, or you can write down these Facebook comments. I expect that because you are a genius. If you have not taken interest till now, you may take interest now, because interaction among engineers is very important. You cannot stay in design whole life. Sometimes you have to come to contracts, and even if you don't come to contracts, you have to come to quality, you have to come to planning, you have to come to safety, or you have to come to method statements writing, or you have to deal with those people, or you have to do whatever you want to do. You may be arbitrators one day according to law of every country. Engineer is also an arbitrator. Engineer can be appointed an arbitrator, like advocates, like chartered accountants, and like whosoever is given in that. Every country has that. If you can be given, say you are given an opportunity after 10 or 15 years experience, though it's now 10 years because it was 15 years. Okay, no problem, 10 or 15. Question is what value you have, which field you work in. That's very important point. Sometimes we want to raise ourselves, we want to rise ourselves, but we don't want to understand that rising is not free. You have to learn, you have to spend time on profession. Only then we can rise that point. If you miss, if you understand, it's not goal of life is that you have to be expert, and when you are expert, you are professional. Expert does not mean that you know everything of that, but you can solve problems. You can solve problems that arrive in, which is basic job of engineer. Use of mind is basic job of engineer. Use of your internal brain, your capacity to solve, your capacity to understand. That's where we say engineer is required, where application of genius is required, that is engineer. Where application of a thinker is required, that's where is an engineer. Engineer is a thinker, engineer is genius. And if you say, I can think that, you say means you can think that. You should be travel. You have to travel, because I have seen people, but not you can say, I am well well, you can say on that page. With that, there there's there's a movement required. You can say there's something required on that, and that's very important part. We have to change something. You can say we have to change something in direction. In that direction, that's very important point. If we do not do at this stage, we can never do. We have we have to learn contracts. We have to learn quality. We have to learn scheduling. We have to learn safety, health, and environment, and we have to learn quantification. We have to learn specification. We have to learn technical method writing. We have to learn execution statements. We have to learn self proofing rather than proof choice by others, proofing by others, proof. No, we have to do ourselves. We have to learn handling, how to handle with human resources. We have to learn how to handle equipment. Means there are so many channels open for us to learn and to teach. Learning and teaching are interrelated. Sometimes we learn and sometimes we teach. Both are equal. Sometimes we learn because that is different field for us, or we can learn for improvement. That's very logical point. Improvement, and if you improve, that's best way. Improvement continues, and there is no end to improvement, because improvement is improvement. That has to be taken care of itself, and that's what I say. We should not take it lightly, but we should take it seriously. How can we do that? That's very important point in every of our sub-disciplines of civil engineering. So I was very serious about soil. I talked little about soil. I was very serious about organizational management or field management or field organization. I talked a little about that. I was very serious in you know in contract. I talked a little about it. And like that, I keep talking, that whatever my views reach you, if you have time to spare for this kind of very little level talk, I think that's where we stand now. I like to take your leave for today. Though today has been 2 videos, no problem. Let us see how we move in this world. Let us see how we can work in this world.